Think about the last time you sent money online, or even just posted a photo to social media. Behind the scenes, you relied on a middleman, a bank, a payment app, or a tech giant to process that action. These middlemen act as the ultimate authorities for our digital lives. They hold the master ledger, meaning if their database says your bank account is empty, the rest of the world accepts that as reality. Look at this diagram showing how organizations arrange their computers. On the left, we see a centralized model, where everything connects to one main hub. But on the right, we have a distributed system. Tech giants realized early on that a single central server was a massive liability. If that one computer goes offline, the whole service crashes. So they decided to break apart that single hub, spreading the workload across a vast, interconnected mesh of servers. In these large corporate networks, thousands of machines constantly talk to each other to stay perfectly in sync. They depend on their neighbors to maintain an accurate, shared state of the system at all times. Spreading the database out definitely made our apps faster and highly resilient to outages. Yet the authority over all those servers still belongs to one single company. That single ownership creates a massive hidden vulnerability. Even with 1 million servers working together, they are all controlled by the exact same entity. Because they share an owner, these machines operate within a closed perimeter. They are programmed to blindly accept data from any other server inside that perimeter as absolute truth. We can see this perimeter on the left side of this technical diagram. That red dotted line represents a trust boundary encircling the whole network. Every computer inside that line inherently trusts the others. If a malicious hacker or even a corrupt employee breaches that boundary and alters a record on one server, the surrounding machines won't question the change. They will simply copy the error across the entire system. The tech industry engineered systems to survive hardware failures, but the records themselves remain vulnerable to the decisions of the entity that controls the master key. This is where a new structure comes in. A blockchain is a type of ledger deliberately designed to be immutable. Once a piece of data is written into it, no one can delete or reverse it. The system achieves this by grouping new transactions into a digital container, known as a block. This block holds the transaction details, a precise timestamp, and a specific reference to the block that came immediately before it. That reference is created using cryptography to generate a hash. You can think of a hash as a unique digital fingerprint, generated directly from the exact contents of that specific block. To build the chain, the system takes the fingerprint from the first block and embeds it deeply into the mathematical foundation of the next block, linking them together permanently. If someone tries to go back and alter an old record, the data inside that block changes. That immediately alters its fingerprint, which breaks every subsequent mathematical link down the line, instantly exposing the tampering to the entire network. Rather than relying on a corporate security perimeter, blockchain secures data through objective mathematics. But mathematics alone isn't enough. For this structure to actually resist manipulation, the computers maintaining it must be entirely independent, with no single person or company owning a majority of them. This requires a peer-to-peer architecture. In this setup, every computer on the network is an equal participant, and absolutely no one is in charge. Looking at our network diagrams, the peer-to-peer model sits at the core, an intensely decentralized system. In a peer-to-peer blockchain, notice how the red trust boundaries isolate every single computer. They do not trust each other. They independently verify every piece of information received. Operating in a strictly trustless environment actually maximizes security. Before any new data is accepted, a global consensus of independent machines must calculate and agree on its validity. By combining cryptographic links with independent validation, we finally have a way for two strangers to establish a secure agreement over the internet without needing a middleman to oversee it. While originally invented for Bitcoin, this architecture serves as a foundation for managing any digital asset of value. Take global supply chains. A blockchain can record the physical journey of a product from a factory floor to a retail shelf, creating a permanent, auditable log that buyers can verify instantly. It also enables smart contracts. These are digital agreements written in code that automatically execute a transfer of assets once specific conditions are met. automating the settlement process that previously required manual escrow. We can apply this to civic systems too. Trustworthy e-governance platforms can use immutable ledgers to log votes or critical public records, severely limiting the potential for voter fraud or manipulated data. Even local utilities can adapt this model. Homeowners with solar panels could sell their excess energy directly to their neighbors, with a ledger tracking the distribution and payments automatically. Stripping away the centralized authority streamlines complex transactions, resulting in systems that operate with higher efficiency and complete transparency. For decades, we have been forced to place our digital trust into the hands of human institutions, which are always vulnerable to errors, hacks, and corruption. Now, we can anchor that trust to objective math. It ensures that as we move deeper into a digital society, the records of our transactions and identities are resistant to unauthorized modification.